thank you to Shopee for inviting us here and hosting us today. This is a beautiful office. It's great to see the growing community here. I think about 89 people registered and 73 of you were new to the community. So we're definitely going to be doing some more events over the coming months and years. So thank you all for coming today. Everything that we'll share today, we will provide recordings out to you. So please do share them with your colleagues and through any different channels. Also, too, please make an effort to speak with each other. We've been connecting some dots, some of you trying to solve the same problems with ClickHouse. If you have any questions, please find any of us that are wearing the ClickHouse shirts kind of around the room as well here. You want to, Johnny, do you want to? So yes, we've got Derek Chia, our senior support engineer, who's in the back of the room here. He'll be speaking. Shi Cheng, who just joined us a couple of weeks ago. Welcome to ClickHouse. Johnny Mirza, who's fairly new, started about 3 months ago, and will also be speaking shortly here. And Cheryl just joined us to run field marketing, so she's the newest member of the team. So taking a look into the agenda for tonight, Johnny will give a little bit of an intro shortly here, and then we'll hand it off to Derek. We normally like to run a little bit of best practices from our side. If in the future there's any specific items you'd like us to address, please let us know, and we can certainly deliver. Then we're going to have Frank Chen from Shopee talk on distributed tracing with ClickHouse. And then Johan has flown in all the way from France to give a little talk on hunting non-optimized queries with ClickHouse. Johan's been using ClickHouse for what, over 5 years now? Yeah, so he's pretty astute in the ways of ClickHouse. He's also looking for a job in Singapore. So he's come all the way over here. So if anyone is looking to hire any great ClickHouse talent, speak to Johan. And we'll raise your hands during the event tonight. If you guys have any questions, please do ask. So with that, that's it. Let's begin. Johnny, you've got a couple questions you want to ask the folks here?
I've got to wear 2 microphones today. All right, so thank you for having us today. And just going to go through a quick little introduction to ClickHouse. And I appreciate that most of you probably know what ClickHouse is, but it is a public meetup. So we just want to just ask a couple of questions to see who is familiar with ClickHouse. And I apologize if they're really, really, really simple. We are going to run a QR code. If you guys want to do this, it's a great little warm up. We'll get some real-time events, not ClickHouse real-time events, but another database that will provide that. So have you heard of ClickHouse? Let's test this poll out, and hopefully Cheryl, it all goes well. All right, this should be interesting. Okay, wow, that is amazing. 100% of people, that's a great answer. I've heard of ClickHouse, that's amazing. Being here today. I didn't write these questions, by the way. Okay, we got a no. All right, that's interesting. A couple of no's. Excellent. Thank you for that. So a little bit of test of knowledge for ClickHouse. And once again, I apologize for the simplicity of this question, but I'm going to ask anyway. All right, so what is ClickHouse? Is it an OLTP database? Is it a key value store system? Is it a document store, or is it an OLAP system? Okay, 100% of the answers. I wish we could see how many people got that. All right, okay. Skewing a little bit. All right. Okay, that's interesting. I reckon that was Paul. You did that, didn't you? All right, excellent. And it just kind of helps frame sort of the introduction as well. But yeah, it is an OLAP, online analytical processing database, different to OLTP, which we'll get into in a little bit. Thank you for that. Okay, so a quick little introduction. So now that 100% of people have heard about ClickHouse, and most of you, or pretty much all of you know it's an OLAP database, so I'm not going to go too long on the introduction, but just at a high level. I wanted to talk about ClickHouse from a functionality perspective and a company perspective. So it was created back in 2009. If you're not familiar with the foundation of where ClickHouse was created, it was really created to solve problems around AdWords and real-time sort of analytics on top of web sort of data. So it was created back in 2009. It's one of the fastest growing databases that has ever been out there. I think Spark is probably beating it, but ClickHouse is very close to being second from an open source contribution, GitHub contributions, and GitHub stars as well. So a very popular open source database. So I just want to put some background around that. It is column orientated. So the whole OLAP database is column orientated. So basically every single column gets its own file and stored within its own file, which is what makes it super efficient, great for things like sorting, group bys, those sorts of things as well. It's also distributed, so you can run it in very big clusters. I'm pretty sure Shopee's got some very big clusters running ClickHouse, so very distributed database as well. But it is an OLAP database, so it's meant for online analytical processing. It's not a transactional database. And I've got a really cool visualization of row-orientated versus column-orientated. And this is actually a snapshot from our website. So as you can see, if you're using a row-orientated database for analytics, you're going to eventually hit some performance issues, which is why ClickHouse was created, to have that columnar store and only filter or group by the specific columns that you want to run your queries on, which is what makes it so performant. It's not a transactional database. It's very much for analytical workloads. And it's a really cool visualization to show how that works from our website. Now, there you go. So interestingly, how is ClickHouse being used? There's lots of different use cases for ClickHouse. And typically we see these three main use cases across our customers. And I was talking to Frank earlier. I think we could probably put Shopee in every one of these use cases as well. Everything from observability. You can see Cloudflare is actually one of my favorites. I run a similar setup at home, collecting all of my DNS logs from my home network, seeing when my kids are on Roblox, all that sort of stuff. It's great. It's really cool. Cloudflare does something similar to collect all of their DNS entries. Not only do they use that for their internal observability, they also use that for their external observability as well. So they provide those metrics out to their end users to be able to see the health of their DNS services and all that sort of stuff. And you can imagine millions of users accessing that data. Both internal and external analytics. So lots of data warehousing. ClickHouse is sometimes called the real-time data warehouse. We get that quite a bit as well, where we're starting to see a lot of, I guess, migrations from some cloud data warehouses into ClickHouse to run those real-time workloads as well. So both for internal and external user-facing analytics are built into applications as well. Okay, so yeah, just very basic. I'm not going to spend too much time on this, but it is SQL-based. It runs basically SQL. You create a table very similar to any other SQL platform. Lots of great functions. There's always new functions being released, and I love Alexei's calls where he's on the YouTube video talking about all the new functions and things that have been released. But great functionality in there, things like low cardinality, being able to sort of create a lot of unique values in there as well and create a dictionary around that. Array functions, being able to split out by string and JSON objects and those sorts of things. So really great functionality within ClickHouse. And even things like map, so being able to transform data. Really, it's the whole merge tree engine that makes ClickHouse unique. So what a merge tree is based on a logical structured merge tree. So everything is essentially split up into its own file based on an insert, and then it gets merged over a certain period of time. And this is important when we talk about the architecture later on. So the merge tree engine is what provides the deduplication, the compression, and all of the value that ClickHouse provides. It's really the power behind ClickHouse is the merge tree engine and how it stores data. And I won't go into the order by, sort by key, because I'm pretty sure Johan's going to talk a fair bit about that in his slides and best practices around that. But there's other engines as well that have evolved from the merge tree engine. So things like replacing merge tree, which will do, obviously, remove duplicates from certain records, or collapsing merge tree, which is really good for, I guess, updating data. So I did have a question on that, but that's okay. So it's good for updates. And then aggregations is really powerful, especially in combination with materialized views, where you want to run materialized views on aggregated data. Lots of different integrations. Everything. We see Kafka and probably S3 as the two main integration points for ClickHouse. They're the two big ones. Obviously there's some table engines for MySQL and Postgres and those sorts of things as well. So just a bit on inserting data. There's really two ways to work with ClickHouse. Traditionally, it's a batch-based system. So you want to batch data or as many rows as possible into ClickHouse and basically batch that in. So millions of rows, for example. And what it does is when you create an insert or a batch, when it writes that file to disk, it creates a hash for every single file that is created on disk. And that file is then, once another insert is created, that hash is compared with each other and any deduplicates will get removed within there as well. So that's how the merge tree engine works, is essentially creating that hash, creating files on the disks, which eventually get merged and merged and merged into bigger parts. If you think of a big tree structure, it kind of does look like that. But there's also, and that's really good for things like S3 and bringing in data from batch-based systems. The other way is really good for things like Kafka and other queuing systems is called asynchronous inserts or async inserts, where you can enable row by row inserts into ClickHouse. And then ClickHouse will keep that data in memory for a certain period of time. And once it hits a threshold of 200 milliseconds by default, it will automatically batch that data onto disk. And then it will start the merging process there as well. So really good for Kafka type deployments. So within ClickHouse, there's once you got the data in, so you've created the data, you've inserted data from whether it's a async insert or a batch insert, you got some data in ClickHouse, it's been merged, all the hashing's there, the deduplication's been done, then you want to query that data. And there's lots of different ways. So essentially there's a query or what we call a view, where you can save a view within ClickHouse. It's really just a saved query. So you've already created the query, you want to save that, you can reuse that query. Now with ClickHouse Cloud, also ClickHouse, the latest release has got security controls around views as well, where you can share and only provide certain views to certain users, which is really powerful. And there's other types of views as well, like parameterized views and other sort of very useful views. But the really powerful one is around materialized views. So anyone that's used Kafka and stream processing in the past, it's kind of similar to that, probably better. So Kafka has to read the data first, run the process, then write it back to a topic or write it somewhere else. A materialized view is triggered on insert. So as the data is batched and then that hash is created, the materialized view is triggered straight away, which is instantaneous. So there's no reading and writing, there's no extra IO of reading that data. So really powerful to run that aggregation summary of the data and then write that back to another table that you can use and it's been materialized in real time. So very, very powerful features there. We'll go through that. So two more slides for me. So I just want to talk about just a high level architecture. An open source deployment might look something like this, where you've got multiple servers, multiple replicas and shards that may host different copies of the data. And then you've got your keeper layer, which is the metadata, just keeping all the DDL and all of the metadata of all the different servers, of all the different tables in there. Really important to make sure that you have a quorum and there's an an odd number of keepers there as well, so that there's always a leader that's been elected. Lots of questions around multi-region, multi-region type deployments, not just sort of within the data center, but multi-region, to be able to see, to make sure that that keeper is available. That's always going to be the trade-off. Is not so much the data, it's always going to be who's the leader. If I lose a keeper, what happens? I've got two left. Okay, how do you cater for those types of scenarios? So that's kind of a typical sort of ClickHouse architecture. And that scales out. The servers will scale out. I think the largest cluster we've seen is 4,000 servers, which is quite big in a single cluster. So very big deployments. And the last slide from me, I just want to touch on the ClickHouse Cloud architecture because it is fundamentally a bit different, well, fairly different to the on-premise self-managed ClickHouse. And yeah, there's kind of a few reasons for this, but the main point is it's separate. So what it's done is we've separated the control plane from the data plane. So you can see the control plane on the right where you've got your UI, all of your admin functions, your monitoring, your alerting, automation. That's part of the admin sort of control function. Now within the data plane, which is where the data lives, essentially it consists of a load balancer that sits in front of ClickHouse servers and it will round robin between all the different servers. The real differentiator is the separation of storage and compute. And that's a bit of a big game changer in terms of architecture. And there's lots of phases to the separation, storage, and compute. There's other challenges with separating the storage. So for example, the servers become very ephemeral, where you can scale up, scale down. You can switch off the servers or go into idle mode, for example. Like all those benefits come with the separation of storage and compute. And now the storage lives on an S3 object store or within an S3 bucket. Now, when you have that challenge, then S3 is not the fastest disk in the world. So we've created like a caching layer that's been built on top of the ClickHouse deployments. And there's other challenges with that. For example, each server will get their own dedicated cache. But then because the server has to shut down or it's idling or it's scaling out, if that cache is not available, then you might get a slow hit and it has to go back to the S3 object store, which can be slow from a performance perspective. So there's challenges around how that caching works. And then we're working towards building more of a distributed cache layer where it's shared across all the different servers and it's not individual to every single ClickHouse server. So it's a great feature, it's amazing, but it does bring a bit more complexity around caching and then how the merge operation works as well. But that's what the ClickHouse Cloud architecture looks like. All right, cool. So I think that's all. All right, just want to say thank you, everyone. Thank you to the speakers. Thank you for attending today. We're going to hang around a little bit, but please join some of the community Slack, some of the community pages. I just had a quick look. There's almost 7,000 community members on the Slack channel, which is great. We're constantly answering questions as well. So please jump on and feel free to reach out to us. If anyone wants to speak at a meetup in the future as well, please let us know. We're definitely going to come back and have more sessions for ClickHouse users in Singapore. And yeah, so we're going to hang around a little bit more. So thank you very much for your time and Shopee for hosting as well. So thank you, everyone.